Okay, welcome 5A. Today we'll be going through question 8, 2017 media exam paper. This question is about statistics cumulative frequency curve. In part A, you are shown a cumulative frequency curve of 120 plants. So there are a total of 120 plants. And if you know how to read the cumulative frequency curve that you learned from last year, you would have known that the tallest plant, in this case, tallest plant, let me just plot if you can see my red line. Here, the tallest plant is 39 cm. That is the tallest one. Alright, so this is a graph plotted from the shortest plant, which is the first plant, all the way to the tallest plant, the 120th plant. Use your graph to find the median. Median means the middle position. Q2, that is the middle position. There are 120 plants. We are taking a look at how the 60th plant look like in the middle, the height of the 60th plant. If you see me plot with red pen, you know it's 20 cm. So the median, which is Q2, your presentation should be Q2 is equals to 20 cm. I want the 40th percentile, so we need to find 40%. 40% of 120 plants. So 40th percentile, that will give you the 48th plant. They want to know how tall is the 48th plant, rank 48. So if we take a look clearly, we need to determine one small little box is how much. If 5 small boxes is 20, one box is 4. So it's like 4, 8, 12, 16, 20. If I want 48, it will be 4, 44, this is 48. This is the 48th plant. So let's take a look at the 48th plant, how tall it is. This is the 48th plant. This is 15, 16, 17, this is 18. So the 48th plant is 16 cm. So 40th percentile. The presentation should be a P with a small 40. There's a 40th percentile that is 18 cm in height. The interquartile range. Interquartile range is the third quarter minus the first quarter. How to get the third quarter? The third quarter is in between the median and the highest, the tallest plant. So the third quarter will be at 90. Here, this is the way to find Q3. Okay, half a box in O levels counts. So you must calculate half a box. This is 90. And if I plot downwards, you will see that the third quartile is 25. Between 0 and 60 will be 30, and 30 will be here. This will show you your lower quartile, Q1. Half a box counts. And this end result is also half a box, which gives you 14.5. So upper quartile is 25, lower quartile is 14.5. Upper quartile is 25, lower quartile is 14.5. If you press your calculator, you will get 10.5 cm. That is the interquartile range. Alright. Now, part 2 asks you to use the graph to estimate the value of H given that 10% of the plant. Now, 10% of the plants, obviously, we got to find what 10% of the plants, how many plants. 10% of the plants, let's calculate. We have 120 plants. So 10% will be 10 over 100 times 120. That would be 12 plants. They say that 12 plants have a height of less than HCM. What is the value of H? 12 plants. Let's search for 12 plants. 12 plants is here. have a height of less than h. So what is this value? 5, 6, 7, 7.5 cm. So there are 12 plants that have a height of h cm. H is 7.5 cm. Because only 12 plants have a height of less than 7.5 cm from the graph. Okay, anything below 12, rank 12 is less than 7.5 cm. Next, one plant is chosen at random. Find the probability that the plant has a height of more than 29 cm. Let's plot on the graph more than 29 cm. I'm going to highlight in yellow. So more than 29 would be from here all the way to here. So this yellow highlighted part will be the part that is more than 29, because this is 29. So I'm just going to plot up 29. I'm going to plot across. There you go. So I'm going to highlight. This part of the graph is the plants that are more than 29 cm. So let's see how many plants are more than 29 cm after I finish highlighting. Okay, so this is the amount of plants. Here, there you go. So how many plants are there? Remember just now we discussed that one little box is 4. So let's count how many boxes are there here. 1, 2, 3, 1, 2, 3, 4. There are 4 boxes. 4 boxes. One box is 4, so there will be a total of 16 plants. Okay, 16 plants are more than the height of 29 cm. So answer is 16 plants. So the probability of choosing a plant that is more than 29 cm would be 16 over 120. Just now we concluded that 16 plants are more than 29. So 16 divided by 120. You should get 2 over 15. That's the probability. And we are done. Now part B question is something that we have done before. We're talking about a ball, unbiased dice, containing red, blue, and 2 green balls. The rule of the game is if the red ball is selected, the score is the same as the dice. So it's the same as the dice. So 1, 2, 3, 4, 5, 6. Done. If the blue ball is selected, the player's score is twice the face value. If it's twice the face value, it will be 2, 4, 6, 8, 10, 12. Now, if it's the green ball that is selected, it is thrice the face value, means multiply by 3. So this is 3, 6, 9, 12, 15, 18. Same for this. 3, 6, 9, 12, 15, 18. Find as a fraction in the simplest form the probability that the player score is at least 15. At least 15 is here, 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 here. So there are 4. So probability of more than 15, the score is 4 out of 24. You must simplify, you get 1 out of 6, and we are done. Now part 3 is the more difficult one. It says the probability of a player scoring an 8 in the game is 1 out of 24, which is true. If you look at the entire table, there's only one value of 8 out of 24. That's why it's 1 over 24. They ask you to find the number of blue balls that need to place inside the box to change the probability to 1 over 9. That means I must add some blue balls. However, if you notice, the moment you add one blue ball, every blue ball that you added, there will have 6 additional. So 2, 4, 6, 8, 10, 12. That is just one blue ball. You add one blue ball into into this, there will be 6 additional possibilities. So one blue ball will become 6. So you see, if I let the number of blue balls bx. Okay, so initially it's 1 out of 24, right? The moment I add, okay, if I let the number of blue balls be x, this will be x. Because one blue ball only gives you one value of 8. However, it will add 6 total different possibilities. So instead of 24 plus x, it will be 24 plus 6x. Because this is blue, correct? This is the number of, this is the probability of the player scoring 8. This is the total, correct or not? And the total is multiplied by 6, because every one blue ball that you add, okay, you add 6 total probabilities, and that is equals to 1 over 9. Because you want to find the number of blue balls that needs to be placed to change the probability into 1 over 9. From here, fraction equals to fraction, you cross multiply, you get 9 plus 9x equals to 24 plus 6x. Shift around, you get 9x minus 6x equals to 24 minus 9. This one you get 3x equals to 15, x equals to 5. So you need to add a total of 5 blue balls. And that's all I have for you today. Finish off question number 10, which is the last, finish off question number 9, and do the corrections for this question and post them on OneNote for me by 2 p.m. today.